a meter rule balances horizontally at the 48 centimeter mark. When a body of mass 30 gram is suspended at the 3 cm mark, the meter rule balances at 0.40 cm mark. Calculate the mass of the meter rule. Okay, let's have a sketch. Right, this is the sketch. Now the meter rule is 100 centimeter long, and it balances. The information we had is that the meter rule balances at 48 centimeter mark. There was no information that tells us that the meter rule is uniform, so that means it does not balance really at the 50 cm but the 48 centimeter mark. So this is the center of gravity of the meter rule, right? So that means its entire weight appears to act at the 48 centimeter mark when it is freely suspended on a knife edge. Now, so that means from here, from 0 to this particular point is 48 centimeter mark. From 0 mark to where we have the weight W here is 48 centimeter mark. Okay, now when a body of mass 30 gram is suspended at the 3 cm mark, the meter rule balances again at 0.40 centimeter mark. So which means we shifted the fulcrum from this point, from the 48 centimeter mark to the 40 centimeter mark. Immediately the 30 immediately when the 30 gram is attached at the 3 cm mark, that 3 centimeter mark. So which means when we put a body here, a body of mass 30 gram, then the equilibrium shifts to 0.40 centimeter mark. Right, so this is where the meter rule now balances at the introduction of mass 30 gram. Okay, so it means from mass 0 centimeter to 3 centimeter is where we suspend 30 gram mass, and then this is where we have the new balance point, which is 40 centimeter away from 0. So all we have to do now is we need to know the distance between the mass suspended and the fulcrum. Since from this place, from this end to this fulcrum is 40, and from this end to the point of suspension of the mass is 3 centimeter. We just take 3 away from 40, so we now know that from the suspension point of suspension of the mass to the fulcrum is 37 centimeter. Take this 3 away from 40, then we get the distance between the mass, the perpendicular distance between this mass and the fulcrum is 37 centimeter. Then the next effort again is to determine the distance between the fulcrum and the weight of the meter rule, which acts at 0.48 centimeter. Now we know that from 0 to this place is 48 centimeter, and also from 0 to this place is 40 centimeter. So take 40 centimeter away from 48 centimeter, we are left with what? 8 centimeter. We are left with what? 8 centimeter. So that means the distance, the perpendicular distance between the weight of the meter rule, which acts here, and the fulcrum is 8 centimeter. So we have found the distance between the weight, the perpendicular distance between the weight and the fulcrum as 8 centimeter, and the perpendicular distance between the suspended mass 30 gram and the fulcrum as what? 37 centimeter. Now let's go ahead and do some stuff here. Okay, now we have to say we have given the mass of the meter rule the symbol, the letter W, which letter W to represent the mass of the meter rule, which is in grams. Now, if we are taking the moment about the pivot now, about the fulcrum, we know that the W will constitute clockwise moment. Clockwise moment is due to mass W, and that will be the product of W and perpendicular distance from the fulcrum, which is W times 8 centimeter. Similarly, anti-clockwise moment is due to this. This mass will cause the body, the beam, the meter rule to rotate anti-clockwise. Okay, it pulls it down and causes it to rotate anti-clockwise. So the anti-clockwise moment, therefore, which is due to 30 grams, is going to be the product of 30, that's 30 grams, and the perpendicular distance, 37 centimeter from the fulcrum. So that is 30 times 37 centimeter. Right? So this is the anti-clockwise moment. This is anti-clockwise moment, while this is clockwise moment. Now, at equilibrium, we have that total clockwise moment is equal to total anti-clockwise moment. That is the principle of what? Of moment. The principle of moment states that at equilibrium, total clockwise moment is equal to total anti-clockwise moment at a particular point. So, if that is what we have, then we have to equate this clockwise moment and anti-clockwise moment. So what we have is this. This is total. This is clockwise moment equal to anti-clockwise moment. So we now evaluate this to solve for W. So we have that W is going to be 30 times 37 all divided by 8, and that gives us 138.8 gram. Right? So the mass of the meter rule is found as 138.8 gram. Again, take note of what we did, how we calculated the distance between mass 30 gram and fulcrum, and how we calculated the distance between the weight of the meter rule and the fulcrum. Again, note that the first balance point is the point where the weight of the meter rule actually acts. Okay, now we add the next balance point when mass 30 gram was introduced. Okay, so therefore that formed the basis of our calculations. Right? The principle of moment remains that at equilibrium, total clockwise moment is equal to total anti-clockwise moment about any point. Right? I hope you've enjoyed this video, you've learned something new, or your knowledge has been reinforced. If you actually like this video, I have a good news for you, which is that we always produce new videos on relevant topics in physics. So I will appreciate it if you can like this video and subscribe to my channel, and much more. I would like you to watch my next video. Thanks.